Welcome everybody to week 8, day 1, or just week 8, because we meet once a week for IS50B besides the in-class meetings. So what we're going to talk about today is how to make an animated character in Unreal Engine. I know we've kind of talked about this a little bit before, but I'd just like to run you through the process of making blend 2D blend spaces and all this kind of stuff. So step 1, you go to Mixamo and pick a person that you want to import into your world. I'm just going to pick one at random or something that looks cool. Maybe this person here, army dude kind of thing, or maybe this God of War type character. What do you guys think? What do you think I should pick? SWAT team guy.
Yes, actually.
You like the SWAT team
guy sounds good.
Yeah.
Alex? Or, I guess...
You like that one, or you like Alex better?
Alex, yeah.
Okay, we'll go with Alex. Okay. So, Mixamo is run by Adobe, and it's just free art assets and free animations and things like that. So you can click on the characters, pick a character you like, and then what you're going to do is you're going to download that character, and download it, and we're going to save this to the desktop like that. And then inside of Unreal Engine, here we go, we're just going to go over here and make a new folder, and I'm going to call this Alex. Just all the stuff's going to come inside of here. I'm going to click import and import to here, and I'm going to go to the desktop, and I'm going to choose thing that I just downloaded. Skeletal Mesh, yes. Import Mesh, yes. Import animations, nah, I don't have any. A lot of times the rotation on these things is wrong, but I don't remember what it is off the top of my head, so let's just import it and see what we get. Ideally we want no smoothing groups. Yeah, just ignore that if you get that. And then we will just take the Skeletal Mesh and drag it in. Yeah, you can see that the red arrow is forwards, and so the thing needs to be rotated 90 degrees left. That's a pretty common thing. A lot of times their forward is the y-axis, but in Unreal Engine your forward is the x-axis, the red. So we can come in here and, well, I don't know if we really want to bother with it right now. We can clean that up in post. Okay, so there we got Alex, and what we're going to do is we're going to get some animations for it. So we're going to come over here and click on Find Animations, and you can click on basically any animation with any of the models, and you can just kind of see what it looks like. Usually, though, what you want to do is get like a pack that has a collection of animations. For a SWAT person, maybe the basic shooter pack might be the one we want. Let's see. Shooter pack, the full shooter pack. Why does that actually have more? Okay. Let's just go with the shooter pack here. Okay, and let's do that. And I'm going to go to download, and we'll just download that. And there we go, shooter pack, there we go. And I can just kind of close out of Mixamo now. And if I go to desktop, I can extract that directory. What you'll see inside of here is that we've got walk backwards, walking backwards, stop walking, start walking, run backwards. We have strafing. We do. So as long as we have these, I think we're good. And it actually comes with a copy of the skeleton mesh too. So what we're going to do is just come over here, and not here. Close you. Where did you go? Okay. All right. So we're going to come in here, and we're going to go import to build Alex, and we're going to go into the shooter pack, and we're just going to pick all of these FBX files like that. And we make sure that the skeleton is the same one as before. Oops, I hate that. The rotation, I probably should have rotated. Whatever. Convert scene unit, import uniform scale. All right, import all. And then what it's going to do, it's going to import all those files in. And you'll see them all up here, kind of down here. And if you want to see what they look like, you can just kind of drag them out and hit play. You can see that it'll just sit there and repeat the animation over and over again. Obviously not good for a final product, but you know, if you just want to kind of see what the different animations look like, you can do that and just kind of take a preview glance at the different animations. So what we're going to do is we're going to build a movement out of. We're going to actually replace our mannequin here with Alex. Okay. So let's click on you and go to the edit blueprint. And the skeletal mesh here. This animation blueprint's going to have to change. But I'm going to change it over to Alex, Chapter 18 non-PBR, in other words. And if I do this and hit play, you can see that I've got I've got Alex now as my character, but it just T-poses by default because the animation blueprint is completely wrong for it. It actually uses a different skeleton and everything. So what I'm going to need to do is click on the mesh. You can see right here the animation blueprint's gone because it doesn't work. So we're going to make a new animation blueprint, but before we do that, we're gonna put together a movement blend space. Okay, so let's come down here somewhere, right click, choose animation blueprint. We're going to make one of those in a little bit, and we're going to make an animation blend space. And you have to choose which skeleton you want to use. Unfortunately, Mixamo and the Unreal Engine mannequins are different. If you're interested in how they're different, I can show you if I click on the skeleton here. So skeletons are bones, essentially. If I show the bones, character mesh, where are the bones? There. So there is the skeleton for this skeletal mesh. So a skeletal mesh is different from your normal static mesh. A static mesh for a chair is just a chair. It doesn't bend or deform or anything like that. A skeletal mesh has joints and can move. And so a skeletal mesh has like different art kind of for each bone attached to it. And as you move these things around, you can see all the child bones move with it. There is a parent-child relationship between bones and the bones that they're attached to. If I move my shoulder, my arm moves. If I move my elbow, my wrist moves, right? And my fingers and everything below it in the hierarchy. But when I move my elbow, it doesn't move my head, right? So everybody that's a child of the elbow moves when the elbow moves. And so you have to have a skeleton that describes this hierarchy of like where the joints are. The hips right here is the root node, and so if you were to move the hips, if I were to rotate the hips, it rotates the entire body. That's considered the root of the human, the hips. And then if I were to like rotate like the spine or something, you see the legs don't move, but everything attached to the spine moves. Now this is different from undo, 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 undo. Huh. Ah. I don't know why this is. I'll just save you. All right. Redo, 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 redo. Okay. Now, if you want to look at the Unreal Engine mannequin meshes, let's see, third-person blueprint, blueprints, third-person character. Oh, we've already switched it out. Where are you? Mannequin, character, mesh. UE4 mannequin skeleton. So if you look at the skeleton here, the bones, they're named a little bit different. Like they're actually laid out exactly the same way. They just have different names, and so they're considered different skeletons for that reason. If you were to compare these side by side, you see hips, spine, spine 1, spine 2, root, pelvis, spine 0, 1, spine 0, 2. And so there is a way that you can connect the two of them, so you could use animations for one of the mannequins, for one of the skeletons on another skeleton. We're just not going to worry about that today. It is possible. There's something called retargeting, and you can basically tell Unreal Engine the pinky finger, you know, the left hand pinky 1, well, that's the same thing as pinky O1L. You know, you just have to kind of go through this very boring process of just telling each other what the names are. Okay, but we're not going to worry about that for today. So when you're on a skeletal mesh like this, you can see on the top right corner here, you have a skeleton, then you have a mesh attached to the skeleton, and each one of these bones essentially has like graphics associated with it. And then there's animations that are associated with the skeletal mesh, and then there's also something called physics, which have mass and collision and things like that. They affect how like ragdolling works and things like that. And you can put constraints on the joints so that somebody's arm can't move behind their back and things like that as well. So, ragdoll. Okay. So we're going to be making what's called a blend space. And we're going to be doing this on the Alex skeleton. And, yep. Okay. So, we're going to need two axes here. We're going to need a horizontal axis and a vertical axis. And the horizontal axis is going to be the direction we're moving. So if we're looking forwards, we could strafe right or we can strafe left. And so the horizontal axis is going to be called direction. And the minimum is going to be negative 180 one way, which means, or no, negative 90 one way, positive 90, is that right? I guess negative 180 to positive 180. Okay. So does that make sense? If we're running backwards, that's negative 180. If we're running forwards, that's 0. If we're looking forwards and we're running to the right, that's 90. If we're looking forwards and running to the left, that's negative 90. Okay. So this will go from negative 180, negative 180 to positive 180. Number of grid divisions, let's see, that'd be 0, 90, negative 180. Yeah, that seems right. And we can mess with the interpolation in a bit. You'll see that the interpolation actually really matters, because when you switch from like negative 180 to well, like when you wrap around, like a lot of times the animation will glitch out, and there's actually some interpolation you have to do. And then the vertical axis is going to be how fast we're moving. So this will be our speed. So we've got speed, which will go from 0 to, I don't know what our max speed is, 500 or something. We should probably actually look that up. Character movement, max speed is 600. Okay. And so the maximum speed is 600. And what we want, not 60, 600. What we want is that as, like, if we're standing still, right? So if we're standing still, we're not moving. What we want is the person to just be like idle. Okay. So do we have an idle rifle aiming idle? Put that on there. And so you can see that like when we're not moving, it'll just sit there in this idle animation. Okay. And then when we start walking forwards, and you see there's a little green dot on here. This allows you to simulate the animation as you start, as you increase in speed and things like that. And what you do is you have all of these animations in the bottom right-hand side here, and you drag them out to different points on this grid. So for example, walking, might put here, and then running, rifle, run, rifle, aiming, idle, rifle, run to here. And so you can see that as we kind of move the speed up, it'll start moving faster and faster, and it'll blend the animations together. Now, there's a problem with this, and the problem with this is that the root motion is not enabled. And so what happens is that when these people are running, they actually run away from their origin. You see the origin is down here. They actually, like when they move, they'll actually slide forward and then snap back, and then slide forward and snap back. And so one thing you have to do on all of these animations, and I'll just run through these really fast, is turn this on here. Enable root motion, double click, enable root motion, double click, enable root motion. And you got to do that for everything that you want to use. Rifle aiming, I guess it doesn't matter on that one. Run backwards, start walking backwards. And this is why I like getting the animation packs. It just gives you a collection of animations. You see how it moves away from the origin? It looks really bad if you're actually using it on a character. Okay, so there. And when you turn it on, you see that the thing moves, the origin moves with it. So we just turn that on all of them. Walking backwards and walking to dying. There we go. And then let's just come up here and hit save all. So all these things are getting written to disk, and there we go. Let's go back into new blend space here. And now you'll see that as we start walking forward, you can see that the animations, and you see how they like just very smoothly and nicely like interpolate between each other? It's kind of cool, huh? Yeah, I don't know if begin walking is actually something we want. I'm just going to delete that for now. And so basically I've got here this is 0 directions. I'm looking straight ahead. When I start walking forward, it's going to start moving into like a walking animation. And then when I start going at full speed, it's going to, when I start going at full speed, you can see it starts running that way. Okay. So now we need to do strafing. So this vertical column here is 90 degrees to the right. So we need to have a strafing animation. Like maybe right here. And so you can see this is walking forward, and then this is, I think that's maybe the other side, like a left strafe. Let's move that over there. So we're walking forward, and then we go left. Maybe I have that backwards. Maybe that is right. Negative 90. Yeah, I think that was correct. And then the other strafe will go on that side. So you can see, oh, that's like a backward strafe. I don't know. We'll see how it looks. Okay. So that's strafing and run backwards. And so if we're going at full speed but backwards, that's at negative 180 degrees. So that would be run backwards, and that would be this corner up here. So if we're at full speed running backwards, you see that? So this is full speed forwards, and then it's kind of messing up because we don't have a strafe on there. And then full speed backwards. And maybe we'll put the strafe up here. Strafe up here. Okay, so we're going full speed forwards. We start strafing. We start running backwards. You see how the animations just really nicely and smoothly blend in with each other. And yeah, and so you can, depending on how many of these things you have, sometimes you have like a walk strafe, things like that. So Stover, Corrente, you guys have any questions about this? You basically take these animations and you plunk them down on the here. So we got another run backwards on this side right here, because 180 degrees is backwards. Oops. And that's negative 180 degrees is also backwards, right? So direction is forwards. Okay. Okay. So that's pretty good. Let's see if there's any other animations we need to do on here. Walking backwards. Okay, so walking backwards would be here and here. So here's walking forwards, and then it's walking backwards. And we probably should have, we had a walk strafe, which would be really nice. I'll put strafing in between there and see if that interpolates nicely. So here's walking forwards, moving sideways to walking backwards. Okay, and if we're at a stop, we're at a stop. You see that? So down here is at 0 speed. So it doesn't matter what direction we're facing, but depending on if we run forward, strafe right, strafe left, walking, that kind of stuff. It's pretty cool. So there is our blend space, and we should probably rename it to something more useful than new blend space. Yeah, should probably have to play with those in a little bit, but just let that be. Third person character. Okay. So we will just use we're gonna have to make a blueprint for this. Third person idle run T. Let's make a new blend space. Okay. Oh. Alright, so compile, save our viewpoint here. Oh, it's what happened here? It's back to the mannequin again. Third person character. Oh, did I undo that? That's really bad. Let's put you back on Alex. Okay. And then a new blend space is our thing. So compile, save. Now it's not going to work. So watch this. So when we run this, you can see it's just kind of like sliding around. And that's because currently it doesn't actually get the direction or the velocity. Those are words that I typed in on the animation blend space, but they're not actually. It doesn't know that that's supposed to be direction and velocity, so we're gonna have to make it. Okay, so we come up here to Alex, and we are gonna rename this new blend space. It's gonna be called like, where'd it go? Like, super cool movement. Yes. Okay. Okay. So we don't need you. We don't need you. We don't need you. Okay, so we got you. Compile, save. All right. And we'll go to save all. All right. So now we're going to make a animation blueprint to use the blend space in the blueprint. So we're going to come in here, right click, blueprints, animation, and go to animation blueprint. And this will be called, and we're going to target it at the Alex skeleton. And we're going to hit OK. And we're going to call this Alex movement blueprint. Okay. And save, and it'll come back in here. And I will just, before I forget, I will set that to be the animation blueprint. Alex movement. Okay. So that blueprint there is going to be the animation used for Alex when we run around. Okay, so we come up into here, and this is a new kind of blueprint. So this is an animation blueprint, and it works kind of the same way. It's got nodes and things you can attach, but it's got this weird thing as the output, and the output is the pose. The pose is the frame of animation that is going to be drawn for the character. And so if I wanted to do something really simple, I could have it just be on like rifle run, and I can just hook it up like that. And then if everything is set up right, when I hit play, you'll see that it just constantly does the rifle run animation. Oh, what happened here? Did it lose the... motion. Interesting. Huh. Okay, anyhow, so it is just yeah, somewhere in here. I'm probably going to set that. Yeah, it doesn't matter. We're not going to be using that anyway. So the point is that you can have any animation kind of feeding into here. And so what we're going to do is we're going to actually feed the result of super cool movement blend space into here. And currently the animation just has hard-coded direction 0 speed. Let me set the speed up to 600 to make sure that the root motion is correct on this. There we go. Okay. So you can see now it just is always, it's like kind of floating in midair too, isn't it? That's not good. Let's fix that real fast. Third person blue. Drop location down by like 20 centimeters maybe. Let's see. A little bit in the ground. Floating in air again. Okay, that's okay. So you see I just have it kind of hard-coded right now. It just, it's not actually getting the direction of the player. It's not getting the velocity of the player. It just is hard-coded as running all the time. So what we want is for the animation. Geez, look at that. It's a little bit. Whatever. I'm not gonna worry about it. So what I want in this blueprint is for it to actually get the direction and the speed. And so what we can do here is actually have a every time the animation updates, we can pull that in here. And let's see here. Let's go back to where we were before. And so we can right-click on this and turn it into a variable. We can right-turn on this and right-click on that and turn it into a variable. And so we've got a variable here called direction. The defaults compile. Defaults to 0. We have speed. The defaults to 600. So you can see it previewing this way. But when we go to the event graph, what's going to happen is every tick, every time it has to update the animation here for this guy, what we're going to do is we're going to update these two variables. So I'm going to come in here and just be like, get pawn owner, let's see, get velocity, like that. So we're going to get the velocity of the owner, which is the skeleton that's running around. And in order to go from velocity to speed, do you guys remember how to do that? Stover or Crente? So velocity is speed in a direction. But all we want to get is the magnitude of the velocity. Do you remember the node to get the length of a vector?
Length?
Yes, it is. So vector length, and then we are going to just set speed on that. And so that is that. Lined up nicely. So so now every frame that we're moving, it's going to be getting the size of the velocity of us and setting that variable every frame. And then the animation blueprint will be using that in the blend space to determine how quickly we're walking forwards. So if we come over here, hit save, hit play, you can see by default, my feet are in the ground. It's so annoying. When I start walking, you can see it starts animating, and then when I start going full speed, then it's doing the full run animation. Okay. I need to fix that. Okay, either way. So pretty cool, right? That's really frustrating. Pull it up a little bit. It's really annoying when that happens. Okay. Anyhow, so that's just decorative stuff. Then the next thing we need to do is get the direction. And there is a specific node for that I always forget, which is like get it's like yaw maybe. Create vector from yaw pitch. Okay. Get yaw pitch from vector. So, all right. So we can get our forward, right? Okay. So we get our forward vector. So that's the direction we're looking. And then our velocity, we can normalize this. And that gives us the direction we're moving. So there's the direction we're looking and the direction we're moving. And what we want is the yaw, which is the rotation, to get from one vector to the other. And let's see. Get yaw pitch from vector. No. It takes two vectors and it returns the rotation between them. Find look at rotation, maybe? No. Let me pause the recording. I need to look this up. Sorry. I never remember off the top of my head. All right. So the thing I was looking for was calculate direction. Okay. And so we do that by, it takes in the velocity, like that. It takes in itself, and it takes in the rotation, like this. Okay. And so there's basically a hard-coded, or not a hard-coded, but like basically there's a specific blueprint node that does exactly that. So you feed it a velocity, you feed it a direction, then it returns the angle between your velocity and your look vector. And so we just basically drag that out and hit set direction, hook it up, hook it up, there we go. And the value of that is going to go into here. And that should be that. So yeah, that's the node I can never remember. It's called calculate direction. Okay, so save and play. And now when I move sideways, you see it kind of like sidesteps a little bit. Okay. And if I add a sprint functionality to it, you see how the animations kind of all blend nicely into each other. And there you go. So that's how you can do a animation. And yeah, from start to finish, step one, go onto Mixamo, download a model for whatever you want, download an animation pack, import them into Unreal Engine. Then that camera preview is so annoying. Okay, and then you make a blend space for the motion, and you basically put the different animations onto the blend space, like so. Super cool movement BS. And so basically I've got one axis here for direction, one axis here for speed, and then I've got a bunch of animations, and I just kind of put them out where it makes sense. So this column here is for moving at a 90-degree angle, and you can see if I preview it, if I'm walking at about a speed of 300 at a 90-degree angle, it kind of does a walking strafe. And then if I'm at a 180-degree angle, that's backwards, and I've got positive 180. and negative 180, so it actually will not glitch out the animation when it kind of wraps around from positive to negative, which can happen. And so one thing you have to watch out for when you do this is that sometimes the animation, because what it does, it basically tries averaging the animations together. You can sometimes kind of get weird looking effects. This isn't too bad. Like, I'm not super, whatever, by it. But yeah, it's just a nice way of doing like, averaging together animations, and it works just beautifully. Now, how we used to do it back in the day was we would just have a series of static meshes. So rather than having bones like this, back in the day you would just have a static mesh and a static mesh and a static mesh and a static mesh. And so if you wanted to do an axe attack, you would have a static mesh of this, a static mesh of this, a static mesh of this, and you just play 1, 2, 3, 4, 5, and that's your animation, which is fine and all, except you can't combine it with other animations, right? Like if you're running sideways versus running forwards, when you do the axe attack, the person's always probably running forward and swinging the axe. It can't mix multiple animations together because there used to be no concept of bones. Like it would just play frames of animation, and you can't mix them at all. So with a blend space, you can average animations together, things like that, and as long as they're all kind of sensical, then it'll work. Now, if you do something like add firing rifle up in here, then I don't know what to tell you. Like, it's gonna be running, and then you turn to the right, he'll stop and start shooting at like I can't stop you from making bad choices on it. Walking to dying here, it's like if you walk slowly to the left, you'll do that. Like you can make it look bad. You can make it look bad. But assuming you kind of space these things out and get everything set up correctly, it'll work out pretty nicely. So you set up your blend space, then you make a blueprint. The blueprint basically uses the blend space to feed an output pose. Whatever inputs you have to the blend space become variables, and then you set those variables every frame with event blueprint update animation. And you basically set speed every frame and set direction every frame. Speed is pretty easy. It's just the velocity, the magnitude of the velocity. And then for the direction, that's the thing I always can't remember. So you feed the rotation, the velocity into it, and it returns the angle that you're moving at. So that's basically that. So that is a working animation and stuff. One thing you have to be careful about when doing animations is making sure that the speed and the animation kind of line up right. You can see here the character is kind of floating in midair also. I would probably go in and start tweaking things at this point, because when I'm idle, you can see his feet are below the ground, right? They're actually in the concrete. And then when they move, they're up. And so I would come in there and actually tweak those values so that I don't have these weird effects. Another thing to watch out for is to make sure that the amount of ground covered matches your feet, right? Because if you can see the ground's actually moving under his feet faster than his feet are moving, so that's a problem, right? It's like it's maybe not that noticeable, it's not too bad, but you really want the motion of the feet to actually match the velocity of the person. And if you don't, you get what's called an ice skating effect, where it looks like the person's just ice skating, like their feet are moving like this, and then the ground's sliding underneath them, and it looks really bad. This one, I would probably come in and, like I said, I'd probably come in and tweak it a little bit, but it's not so bad. It would be jarring to me. All right, so that is character animation, importing, etc., etc. Any questions? You learned in fall IS50A. Yeah, we did a little bit in IS50A. With root motion, yeah. It just is going to take a little bit of tweaking. It's not the end of the world. It's just, if you're making a professional product, you wouldn't want to ship like this. Yeah. So your assignment for next week is just to do that. I'd like to see something funny, maybe. There's lots of amusing animations on there. You can also make it the animation blueprint like work with like attacks and things like that. So like if the player is attacking, then it fires the firing thing like that. Double dagger stab. You know, so you make it so when you click, it does one of those things. So, you know, have fun with it. Maybe we can do that. Did I quit already? I think I quit already. I'll launch it back out. We got 10 minutes left. So, yeah, have fun. You know, import something ridiculous. You know, have some fun animations in it. So we got here Alex movement blueprint, and we can do things like third person blueprints, third person character. We can have what I did in IS-50A was I made like a charged weapon, so you hold down to attack, and then when you release, it fires a projectile. So we can make it so that while we are clicking, pressed, so it just sets clicking time, I can make this a variable. Pull that back a little bit here. Pull you back over here. So when I click, I can set a variable. Let's make a new variable called aiming. And I will make this public so that other people can view it. And I'm going to set aiming to be true. And when we release, I am going to set aiming to be false. Okay. And so basically what I'm doing now is when I'm holding down charge, it's setting a variable, a boolean, saying, hey, I'm charging my shot right now. Do you add attacks to the blend space? You don't have to add it to the blend space. You can do it in the blueprint. And so in the animation blueprint, you can have this. Yeah, now I see what you're saying. Yeah, because right now it's just feeding into the blend space. I don't know if I want to get into. No, that's gonna have to be a lecture for another time. Yeah, sorry about that. Because firing is not one of these options here, right? So there's actually a finite state machine that you do with these things, and yeah, we don't have time to do it today. But this is a setup for next time. So basically, as long as we are holding down attack, aiming will be set to be true. When we release, aiming is set to be false, and then maybe next time we'll do the little finite state machine to have it switch. You know, when you're aiming, it'll switch to one of these things, and when you release, it goes back to running again. Okay, so yeah, we don't have time today to do that, but next time. Okay, so thanks for coming out, you guys. Build one of these things, and I'll see you next week. Peace out.